friends together. Coincidentally, this Sunday it's due. Meeting at neighborhood Starbucks.
This is John Brinkins here, reporting to you from Sports Science here in Hawaii for the Pro Bowl this week. I'm here with Jenny, and she's going to tell us today about energy.
Hi, John.
So, Jenny, what is energy?
Alrighty, well, energy is power derived from the utilization of chemical and physical resources.
So, when Cam Newton runs for a touchdown, that's energy?
Let me tell you, that's a different type of sports science.
Beep.
Well, John, let me tell you about a little thing that we're doing. So within our plant, here in Hawaii, there are many types of energy that we use. The first and main energy that we are using is thermal energy. Thermal energy is coming from the differences in temperatures of the ocean water. The next energy we use is mechanical energy.
So, like a car?
No, wrong one. Mechanical energy is used with the movement of the water, vapor, and ammonia. And the last energy that we are using is solar energy, which is mainly the first...
The sun.
Right?
Bro, I got one right.
We use the solar energy in the first process to heat up the water from the ocean.
That's solid. Damn. H2O, that's the way to go. And for my next guest on Sports Science today, we have George, the next Optimus Spartan Ramirez here. And he's going to explain to us today what Makaya Energy actually is.
Well, Makaya Energy, the project, is really focused on ocean thermal conservation energy, which is something we've been focusing on in Hawaii, and we found that it works best in tropical waters. So areas here shown on this map that are going to benefit from Makaya Energy Project is Central America, Africa, the coast of Africa, Pacific Islands.
Yeah.
But the two areas we want to focus the most on are India and Southern China. These are two areas that suffer from severe pollution due to the factories. And since Makaya leaves no carbon footprint, it means that it's going to have clean energy. It's going to reduce pollution, and it's going to contribute less to global warming. And
1 second, I got a phone call.
excuse me.
2,000 years later,
You know what,
6.5 hours later,
You know what, dude,
a
I'm
few
doing
inches
one
later,
more.
day 2, day 3, day
gotta go.
4, a few moments later.
Well, as I was saying, with cleaner air means greater standard of living, and with cleaner air also comes less harmful effects to humans living in that area, and it's going to reduce the amount of cases dealing with asthma and pneumonia, and cleaner air is better for all the people in these countries.
So you were telling me how it can help, like, the waters. You think you can carry Lake Michigan and take the Bears to the Super Bowl?
Well, it's not what I meant, but I think we both know nothing could take the Bears to the Super Bowl,
Not even Cutler?
especially not Cutler.
Well, there goes my dream. And I'm here with my final guest from Makaya Engineering. We have Rebecca here, and she's going to tell us about how this whole procedure works.
Alright, so here at our plant at Makaya, we have three liquids. We have the deep sea water, which is our cold water. Then we have this surface level water, which is warmed up by the sun.
Solar power.
There you go. And then we have ammonia. So what happens is, here's a picture of it. And we got hot water from here that comes up into this chamber, which is called the evaporating chamber. And then we have ammonia coming from here. This is low pressure ammonia.
Isn't pneumonia like a disease or something?
You're thinking of pneumonia.
Ain't nobody got time for that!
Different things. Another. So we have the ammonia.
That's a
It's
football field, right? Like the field, the bench, the fans, that shit.
I mean, that's a creative thought, but no. These are fans though, so you got one part right. So
Oh, we get rejected.
we're
What's
learning.
new?
So we have the evaporating chamber, and what happens is the ammonia and the hot water collide. And what you're probably thinking is, like, how does this make a difference for anything? Well, the hot water is enough to make the ammonia become into a high pressure steam, because the ammonia has such a low boiling point. And so the high pressure steam comes into this chamber, and
Albert Einstein's light bulb.
you're thinking of Thomas Edison.
Same person, right?
Johnson. You know, you do. And so it powers the turbine, which then powers the generator, which powers the plant and other sources around Hawaii.
Can the plant be a rose?
I mean, you can paint roses around it, but that's not what we're looking for. Then after the high pressure steam from the ammonia, it turns into low pressure, which is then transferred into this chamber with the cold water. So then it becomes even lower pressure and it goes back into the chamber, and it's just a huge cycle.
Takes forever to do that. What, can this be a football game in 60 minutes?
Well, this is a lot more useful than a football.
I don't learn anything out of this. I'm done, guys. I have to go.